So in this video, we're going to talk about how to solve systems of two inequalities by graphing. So a system of linear inequalities consists of more than one inequality. The solution set to a system of inequalities will be the set of ordered pairs that satisfies all the inequalities in the system. So the solution set to a system of inequalities can be found by graphing. Remember in Algebra 1, you had to convert the inequalities to slope-intercept form before graphing because you were using the testing version of Desmos. But now that we're using the full version of Desmos, you don't actually need to do that because Desmos will graph the inequalities even if they are in standard form. So remember, there are some rules for graphing inequalities, and Desmos will automatically take care of this, but it's just good to know. So if the inequality sign is a less than or equal to or a greater than or equal to, your boundary line will be a solid line. And you can see that here in this example where we have y is greater than or equal to x minus 5. Notice that the boundary line is a solid line. If the inequality sign is a less than sign or a greater than sign, the line will be a dotted line. And you can see here when we have y is greater than negative x plus 5, the boundary line is a dotted line. Some people will also call that a dashed line. So remember, we need to use a test point to determine which side of the boundary line to shade. If we plug in a test point, and the one that I like to use is 0, 0, as long as it's not on your boundary line. If you plug in 0, 0 and it makes your inequality true, then you will shade towards the test point. So for example, if we're looking at y is greater than or equal to x minus 5, if we plug in 0 for y and 0 for x, we get 0 is greater than or equal to 0 minus 5. So that's telling us that 0 is greater than or equal to negative 5, which is true. So that's why this is shaded towards 0, 0. If we plug in 0, 0, our test point, and it makes the inequality false, then we'll shade away from the test point. So for example, if we plug in 0, 0 in this second example, we get 0 is greater than negative 0 plus 5, which is basically 0 is greater than 0 plus 5, which is telling us that 0 is greater than 5. So that is false. So that's what you can see in this graph. It's shaded away from 0, 0. I just want to remind you where we're looking when it's asking us to find solutions. So you can see here I have a system of inequalities graphed in Desmos. And notice that my first inequality is in green and my second inequality is purple. Okay, so this darkly shaded region here is going to be the solutions to the actual system itself. Well, if we look at four different points, they're going to be a solution if they're within the overlapping region only. So that's why negative 9, 3 is a solution to the system. Okay, 3, 6, and 2, negative 5 are not solutions to the system because they're solutions to the individual inequality, but they're not in the region of overlap. Okay, so that's what's the difference here. So we would say that 3, 6, 2, negative 5, and this number that's out here, 10, 1, these are all not solutions because they're not within the region of overlap. So I just want to point that out because that's going to be very important as we work through this unit. So now let's go ahead and graph this system and determine whether negative 1, 1 is a solution to the system. So like I said, we're going to be graphing in Desmos. So I'm going to go ahead and type in my inequalities. Remember, you can get the inequality signs here from the keypad. And then we have 2x minus 4. So that's our first inequality. And then we have y, and then less than or equal to negative 1/4 x, and be careful that you're not typing that x down in the denominator, and then plus 3. Okay, so now we can see we have our system graphed here. You can see that this region that's shaded more darkly is going to be the region of overlap. So if we want to figure out whether negative 1, 1 is a solution, a really quick way to do that in Desmos is to just type in that point. Because if you type in that point, it'll show up on your coordinate plane, and you can change the color of it. If for some reason you can't see it well, you can always just click on settings and then change the color. And then you can see here that it is within our region of overlap. Okay, so I do think it's a solution, but I want you to show you that there's another way to also determine if it's a solution. Because remember what we said is that if a point is a solution, it's going to make both inequalities true. Okay, so what we can do is plug this in for x and y into both inequalities. So we would get 1 is greater than 2 times negative 1 minus 4. So that's saying 1 is greater than negative 2 minus 4, which is saying 1 is greater than negative 6, which is true. Okay, but that's only half of it. We have to plug it into both inequalities to verify. So we have 1 is less than or equal to negative 1/4 times negative 1 plus 3. So that's saying 1 is less than or equal to 1/4 plus 3, which is saying 1 is less than or equal to basically 3.25. Okay, and that's also true. So that's why we know that negative 1, 1 is a solution. Okay, so here's that graph. And so now you can go ahead and pause the video and try doing. Okay, so now I have this system graphed in Desmos, and I just want to show you how to change colors in Desmos because sometimes it picks like, darker colors, and I think it's harder to see the region of overlap. So if Desmos does that for some reason, you can just click this settings, this edit list button up here, and then click to the left, and then it'll allow you to change the color. So for example, if you want to make one orange, and I don't know, make this purple, you can change the colors to make it a little bit easier to see the region of overlap. Okay, so I have my system graphed here, and I also have that point that we're looking at, that 4, 2 graphed. So notice that it does fall within the region of overlap, right? It's right here, so it will be a solution. Also, if we plug this point into both of our inequalities, notice that it makes both our inequalities true. So you can solve a system of inequalities by graphing it. You can either graph by hand or use Desmos. After graphing each inequality separately, determine the region of overlap, and this will contain all the points that are solutions to the system of inequalities.